Hi everyone, my name is Stefano Zampaletta and I will try to make you a journey through FUTURECEM technologies.
Starting from the background about the necessity of having a sustainable solution for cement and concrete. As you know, from a global point of view, there is the Paris Agreement to keep the increase of temperature below 2 Celsius degrees. However, in Europe, we also have put a goal on the 2050 as a reference to have a net zero greenhouses emission. However, there is a different way of approaching and solution for this goal. There will be obviously an improvement, I would say, or stricter rules from a European trading system to reduce the free allowances, also the benchmark of CO2 emission. And on the other, I would say, on the other information are coming from the roadmap to follow by the International Energy Agency. Then in Europe, we have the 5C approach from Semburo that cover not only the cement, as you will see, but all the value chain. This is not only for cement sector, but is covering the most emitters, I would say, of CO2 emission in different sector and manufacturing. This is, I would say, the regulation point of view. Then there is also an increased demand of greener building solution from the market. So the idea is to combine the necessity to the opportunity. One of the way is to reduce CO2 emission is to substitute the main emitter in the cement, that is the clinker. However, to substitute the clinker, we need the fly ash and slag that are the most commonly used SAM in the cement industry and also in the concrete industry. But however, they are becoming short in the supply. Why? Because also, I would say, fly ashes and slag are challenged by the reduction in CO2 emission. Fly ash obviously will run out in Europe because there is a switch off program in Europe, while this industry will in the future reduce the production of slag because I would say slag is still a waste for them. So they want to I would say most advanced production process, as well as to reuse the steel through the arc furnace system that is most advanced. So the idea is how to come up with the other solution to reduce the CO2 emission through clinker substitution. On this point, Cementir as Elaborate Group, Aalborg Portland, has elaborated a new technology, I would say. More than cement is a technology that is based on three main pillars. Is green, so is able to reduce the CO2 emission. Is sustainable, because it relies on the most available material on the earth. It is the clay and the limestone too. And then there is innovative, because it's based on the synergy between the limestone and clay, and it also validated. The validation was a very milestone in the process, because was to make real, I would say, structure with the cement FUTURECEM made through green concrete too. This idea has been developed by Cementir Group, Aalborg Portland, and is patented in several areas. Among them, there is US, Canada, and obviously Europe and other, I would say, countries. Just to, I would like to give you the most important, I would say, pillars on which is based. That is the limestone calcite clay, that is the greener and sustainable view. Greener because, as you have already told you, we can substitute the clinker, so we can reduce up to 30% of CO2 emission, even more if in the future the standard will allow us. And then, for sure, that is sustainable, because as you've seen from the picture, is clearly the calcite clay and the limestone are the only material available on the earth to be a substitution for Portland cement and get a very lower CO2 emission, I would say, for cement, and so they clink a very low clinker ratio. Fly ash, slag, and natural pozzolan cannot be a solution for a full conversion towards blended cement. But where we start this journey, we start in Aalborg, where for the first time they question about how to create a CO2 emission reduction of a cement, considering the reduction on fly ashes, and also exploiting another very important thing, to exploit local material, local available material. So without moving material from a place to another, sometimes with thousands miles away. And so from the idea, I would say, take a journey towards is I would say validation. So the first was for sure the FUTURECEM project with the patent application submit. Then there is SEM project, because FUTURECEM, as I told you before, is a technology. So it's not only a cement, but can be also SEM, so limestone and calcite alone. Also to cope with some applications that are, for example, in RMC business, there is a SEM1 plus fly ashes. So in this way, you can provide an SEM material right to the RMC plant. And then there is the milestone that I told you before, the green concrete 2, that covering all the value chain helped us to validate the idea, and then called us that now we are also into Callisto project, so the extension of green concrete 2, and will be another step of development in our FUTURECEM path towards a new, I would say, market segments. Regarding the green concrete 2, that is actually is a key milestone for us, we were able to build with this product to infrastructure, so to bridges, but also to cover the normal application. So to have the idea of FUTURECEM as a flexible material, a cement for any application. On one side, the technology was industrialized. So in that way, we demonstrate that the FUTURECEM technology is suitable for a concrete industry without having too much trouble in the application. And on the other side, there is also FUTURECEM technology is a durable technology, I would say, that allows to produce concrete durable. This is another key milestone, because it can be industrialized, but obviously durability is the most important one from the standard points of view. I would say one is from industrial point of view, and the other one from the standard point of view. This is, as I told you before at the beginning, in Europe we have a SEMBURE roadmap divided into, I would say, two different levels. There is a roadmap on 2030, and there is the roadmap on 2050, that is net zero emission on concrete. Now, just to give you an overview, Cementir is working on the three elements: clinker, cement, and concrete, and FUTURECEM is acting on the cement himself. So this is I would say, from a SEMBURE point of view, where we stand as a FUTURECEM, but also as a Cementir, I would say, approach into address the CO2 emission target. But FUTURECEM is not just a cement, it's a technology. So as you have seen, also taken before, has already been implemented into Aalborg stream and Aalborg cell. So I would say in this way it is for white cement, but this demonstrated the flexibility of the technology from, I would say, concrete and ordinary concrete to extreme concrete, I would say. So this is very important to understand that is a technologies that can able to create binder and the cement able to get the performance whatever we need. So just to keep in mind that FUTURECEM is a technology, is from cemetery with extensive research. It relies obviously on the calcine clay technology and is a proven innovation. This is the idea as a FUTURECEM. Then I would say as a cement, obviously this can reduce the CO2 emission and also enable, this is the main point, enable to produce reduce clinker content concrete, but also exploiting local and large available material. This is very important as a point. And then we have, I would say, a recognition in the International Agency roadmap, because this is a solution, proven solution for clinker ratio reduction.
For further info, please visit our website. Bye bye!